Hello, this is checkpoint 3.4. You want us to use a definition of the derivative to calculate the derivative of the function. Let's write that function first. R of t is equal to, we have a 2t squared plus 3 in the I direction, and then we have a 5t minus 6 in the j direction. All right, now the definition of the derivative is going to be let's call it r prime. R prime of t is equal to the limit as t approaches 0. Let's call it h. H approaches 0 of r of t plus h minus r of t all divided by h. Now this is the definition of the derivative, and it gets really tedious, and hopefully this will be the last time that we'll use it in this class, because we know all the derivative shortcuts already and we want to take advantage of that. But let's do this using our derivative formula or derivative definition. Okay, what is this equal to? The first one says wherever we see a t, we're going to put t plus h. So we have 2, we have t plus h quantity squared, and then we add 3 to that in the I direction, plus, and then we have 5t plus h minus 6 in the j direction. So that's the first one. And then we're going to subtract the exact same thing, r of h. So it's 2t squared plus 3 in the I direction, plus 5t minus 6 in the j direction. Okay, this is all divided by h. And the idea, as you remember, the idea behind the definition of the derivative way back in Calc 1 was to expand everything out and see things simplify. And hopefully they do. So for this first slot, we're going to have, we'll FOIL the first term out. It'll be t squared plus 2th plus h squared, and then everything gets multiplied by 2. So that's 2t squared plus 2 times 2 is 4, t times h. Plus 2h squared plus 3, and this is happening with an I vector, plus, and we'll do the same thing, expand this out. We have 5t plus 5h minus 6 in the j direction. And then let's take that negative and multiply it through. Minus 2t plus 3, or let's put a minus 3. Oh, let's put a plus, and then let's put a parentheses on the negative 2t minus 3 in the I direction, and keeping on with that negative 5t plus 6 in the j direction, all over h. Now, this is where we see things cancel, but we have to be careful before we cancel that we're identifying the appropriate values. Like this is all with the I, and this is all with the I. So those are the things that we're going to combine with the I's. All right, so between these two, we have a, oops, I think I'm supposed to have a t squared over here because we want it to cancel. And so we'll see it cancel. We got this t squared, 2t squared, and this 2t squared with a negative, and the 3 here, and the 3 here. And I think that completes the I direction. So what do we have left in the I direction? We have 2 terms left. We have 4th plus 2h squared in the I direction. And then let's take a look at the j. So in the j components, we'll have this and this. And we'll see that there's a 5t and negative 5t and a negative 6 and a positive 6. And so all we have left is 5h plus 5h in the j direction. Okay. All right. Now that we have that, we notice that there's going to be an h all over the place. There's an h here, an h here, and an h here. So we can take an h all the way out. And there's an h all the way out. And then we would have 4t. Oh, I've left out the limits here. So let me rewrite the limits after we're done here. 4t, and then we have a 2h in the I direction plus 5 in the j direction. Now let's get the parentheses correct, and then divided by h. All right, left out the limits, symbols, and this would mathematically be not correct because we have not yet taken the limit. So all these should have limits in front of it. Limit as h goes to 0, limit as h goes to 0, limit as h goes to 0, and here one more limit as h goes to 0. And it's not until we get to this point where we get to cross out the h's, and now it'll be safe to put the h equals 0. So we can just write one more step. Limit as h approaches 0 of 4t plus 2h in the I direction plus 5 in the j direction. And let's put in h is equal to 0, and we just get 4t in the I direction plus 5 in the j direction. Okay, and that's your result. Now, like I said, hopefully you'll do this one time. It'll remind you of when you first learn about derivatives in Calc 1. But after that, you really can just use our shortcut method. If you imagine taking the derivative of the original function, this is going to be 4t plus 0, 4t, and then the derivative of this is going to be 5, and then you'd be done. Okay, but this is using the definition of the derivative and playing around with the vector value functions. Okay, I hope that helps.